Hello, fellow Scratchers! Are you ready for this? The final piece of the puzzle, episode 4 of our text engine tutorial. And this is where we bring it all together, resulting in a seriously fantastic text and dialogue engine. So we are adding the ability to assign dialogue to individual speakers. So cool! And then we'll bring new text effects like switching color and even more awesome animating effects too. But all this needs to be done in a way that keeps the font sprite easily backpackable and controllable from other game sprites. The trick is to encode in our script list not just the dialogue text, but commands too. Yes, we are literally programming our text engine right now. So we change speaker using the /speaker command and a /R for red text. Get the idea? Yes, that's the plan. And this is going to be a whole heap of fun, so if you haven't already, why not save your project as a new copy? And guys, this is episode 4. Let's get scratching! So here's my original script in the Scratchy sprite. And I want to officially assign this bit of dialogue to the Scratchy character. So we're going to do that by adding a new line to the script list before all the others. Our command begins with a /, always use the same direction /, and then the word speaker, /speaker without a space. That is our speaker command. And then we need another space, followed by the costume name of the speaker in the dialog box sprite. We're going to have a look at that in a second, just to match it up. So where I've written Scratchy with a capital S, if I look in the dialog sprite and the costumes, here is my Scratchy dialog costume. Perfect. And I've also got a costume named Nano, with Nano on the right-hand side of the dialog, so that's really cool. We'll make use of that now. So click back into the Code tab of the Scratchy sprite, and duplicate our change of speaker, and this time put /speaker space Nano. Oh man, I can't wait to get this working. Okay, I'm going to change to the Nano speaker for this bit of text down here. You can of course write any dialogue you like in here, this is just me making use of what I already have. Now, of course, if we were to run the project now as it is, then the commands will just be written out as normal text would be. But if you recollect how our text engine works, we always read in a word at a time before we then display it on the screen. And because of that, we can work out whether that word is a command or not before it's displayed and act appropriately. However, before we plough into that, I notice that our projects start up with the dialog box visible. We should start with a blank slate, so click into the dialog box sprite and find the when green flag clicked, and we'll just simply drop a hide block at the top of that. Now if you run the project, the dialog is hidden, of course the text then just starts up, but that's where this /speaker is going to come in handy. But while we're still in the dialog sprite, let's make the script that'll make the new dialog appear. It'll be an event, so when I receive, and we'll need a new message named switch speaker. Okay. And we'll begin by switching to the new dialog costume. Now, which of these two should it change to? Well, that's dependent upon the current speaker. And if you remember, we have a variable named speaker hash, which is supposed to tell us which speaker is currently speaking. This in turn is referencing the item number in the speakers list, if you have a look at that. Item number 1 is Scratchy, and that is the one who is speaking. So to switch to the correct costume, we need to pull that out of the speakers list. So item, speaker hash of speakers, and that gives us Scratchy, so we just drop that into the switch costume too. And then finally, show to make it visible on the stage. Okay, very exciting, because now we need to code up the actual command parsing. And that is going to happen in the text engine sprite itself. So click in there now. So what we're looking for is the define process single paragraph script. And you'll see that we're very usefully looping through each word of the paragraph, a word at a time. So to detect a command, we need to look for words that begin with a /. And we can do that really easily with an item 1 of word. The first item is the first letter of the new word that we just read in. So check if item 1 of word is equal to the /. If it is, then this is a command, and therefore shouldn't be written to the screen like any other word would be. Therefore, let's bring in an if-else, and we'll pop it straight underneath the get next word of paragraph, surrounding all the other scripts. But we'll process commands first, so move all those scripts into the else branch rather than the then branch. Now, this command detector, I actually want to make this a little bit more specific, just in case we actually want a / to be able to be written to the screen after all. So if we check the length of word, that's how many letters are in the current word, and check whether it's greater than 1, so that if it's just a / it won't trigger. So bring in an and we'll pop that in the right hand side, and the other check for / in the left. So commands have to start with a / and be longer than 1 character in length. That makes sense? Let's process it. Make a new custom block, and we'll name it process command, and add an input named cmd command. And we do not want to make this run without screen refresh, because we might want to put things like wait delays and things in here, so leave it unchecked. Then drop in the process command inside our if, and the input will be the word list, so that we get the full word as the command being passed in. And now at this point, I'd really like to be able to test it to make sure that these commands are being interpreted properly. So drop in a stop all inside our process command. Then when we run the project will just stop straight away. So click the green flag now, and as you see, nothing happens at all. And that means we must have hit our first command. Good news. What was that command? Well, we can just click on this word to find out. And there you are. The word reports that it was a /speaker command. Great, exactly what we wanted to see. Question is, which speaker was it? Well, we'll look at that in a second. For starters, let's just move this define process command script into some free space so that we can work on it freely. Okay then. Bring in that word list again so that we can click it and see the last word read in from our current paragraph. So it starts out as /speaker, which at this point also is the command that's being passed in, since we passed in word as this custom block's input. So each command that we want to be able to process needs its own if, and we can check to see what the command is. If command is equal to /speaker, which is the only command that we're implementing at present, then we expect the next word in the paragraph to be the name of the costume of the speaker that is going to speak next. So we want to get our next word from the paragraph. If I click that now and then click on word, there it is. Scratchy is the next word in the paragraph. So drop that get next word into our if, and then we're going to set our current speaker, our speaker hash. The next word is the name of the costume, but we need the item number in the speakers list of that costume. So in this case, it should be equal to 1. So we need to find Scratchy in this list. The way to do that is to use the item hash in list block. And we're looking in the speakers list. And the thing we're looking for is word, which should be Scratchy in this case. If I click that, it reports item 1 is Scratchy. Perfect. Stick that into the set speaker hash block. So with speaker hash all set up, we can now broadcast to change our dialog box costume. Broadcast, switch, speaker, and wait. If I click that, you can see it does indeed switch us to the correct costume, so pop that after the set speaker hash. And now what else should happen when we change dialog costume? Well, we should reset the page, because this speaker shouldn't show any of the text from the previous speaker. And now, if you remember, we also need to pair that with another broadcast to clear dialog text. And that should really happen before we switch speakers, so that the text disappears and then the speaker changes. Great, that looks good. Last thing to do is to stop this script at the end of the if, so that if we've processed the speaker command, it doesn't go on to try and process any other commands. Yay! Well then, I think we can run this project. Smash the green flag, and let's see what we've got. This time the project doesn't stop, that's good news. No indeed, we've actually got Scratchcat in its dialog box, followed by Scratchy saying, hello fellow Scratchers. Let's click through and see if we can find Nano too. Here's our second page. Oh! As soon as the second page finished, Nano appeared without asking us to press space. However, that aside, the good news is that our text is now appearing on the left of Nano, which is something we haven't seen before. And it's something that we defined in the speakers list, if you remember, the safe zones. But there are a few problems. Firstly, our text is no longer appearing at the top of the dialogue after we switch to a different speaker. And, as we noticed earlier, it's also not asking us to press space before switching speaker either when there's a change. So interestingly, to fix both these issues, what we need to know is whether or not we've already written text to the screen when we hit a command. So we'll go back to the code now, and we need this process command script. Here's where we're looking for the speaker. So before we run the speaker, we need to know, has something written to the screen? If it has, we should wait. So bring in an if before we get our next word, and we'll check to see whether we've written anything to the screen yet. This isn't something we're currently recording, so we'll make a new variable to record this, and we'll call it page is dirty. In other words, it's not clean, it's not empty or fresh, something is written to it. And make this for this sprite only. Okay. So if the page is dirty, if page is dirty is greater than 0, then something else is written to the screen and we need to wait before switching to a new speaker. So wait for skip key. So what makes the page dirty? Let's find the bit that writes letters to the screen. No, not this one, the one above. This is it, the write word custom block, and drop in a set page is dirty to 1 as a first thing that this script does. Nice, so if there was any text on the screen, it'll now be classed as dirty. But when do we clear the screen so that it's clean again? That would be in the reset page. Here we are, define reset page. As well as setting dialog to 0, we also now set our page is dirty to 0 as well. Just clean up the scripts. And let's give this a test. Smash the green flag, and you'll see that the page is marked as dirty straight away. And here we go. So this is where it was about to change to nano, and this time it's asked me to press space. Clicking that now, and we're into nano's dialog. Excellent job. That is looking so cool. Well, all except this gap here at the top of our dialog that shouldn't be there. Let's try and fix that. Why is it happening? Well, it's where our /speaker command is. And if you look at our play script from start to end, where we're looping around each paragraph, as soon as we finish processing a single paragraph, we create a new line. But sadly, our command where we're changing speaker is a paragraph in its own right, so we're always moving on to the next line, even if it was a command, not some text being output to the screen. Well, we now have our dirty flag, so we know whether text has been output. So if page is dirty is greater than 0, we should go on to a new line. But isn't there always an exception? What about if the paragraph is a blank line in itself, without any commands? Well, then the paragraph is going to equal the empty value. So we'll check for the page is dirty greater than 0, or the paragraph is blank. And in those two cases, then we create a new line. Now run the project again, and we've solved that issue. The text is flush with the top of the dialog, and it is for Nano 2. It's almost perfect. Only if we click right through all the dialog to the very end, you'll find we end up in an infinite loop where it keeps asking us to press space and the dialog never actually finishes. Right, well, we know what we need to sort next. And we just happen to be in exactly the right place in the play script from start to end. This is where we have a forever loop that is looping through each of the paragraphs of our script one at a time. So why don't we just replace this with a repeat loop for the length of our scripts list, of course. Not sure why I didn't do that to begin with. Never mind. Just carefully move all the scripts from within the forever loop into our repeat length of scripts loop, get rid of that forever loop, and replace it with our repeat loop. Simple. But when we've said everything that was in the script, we should then close down this dialog box afterwards. We just need to make sure that there's no text left on the screen, because if there is, we need to wait for a key press. So if the page is dirty, that's coming in really useful, then wait for a skip key. And after that, we can close down this dialog. And we do that by setting the speaker to the empty value. And then broadcast our switch speaker message. That will switch the dialog sprite to a costume with no name. And if you go and look in the dialog sprite, you'll find that there's a blank costume with no name. And that is why this is going to work. But it also occurs to me that before we switch speaker, we need to also remove all the old text off the screen. So broadcast clear dialog text and wait before we broadcast switch speaker and wait. And now let's run the project and give this a test. So now we're skipping all the way through all the dialog to the very end. And we're hoping to still see the last press space button, although we might want to swap that for a different type of button for the last bit of dialogue. And then we click the button and the dialogue disappears, as long as you've got that blank costume with a blank costume name in your dialogue sprite, that is. Well, hurrah, guys! This is going amazingly. We could stop right here and be very contented with the amazing text engine dialogue system that we've created. However, we want more. What we want to do now is add in text effects. So these are also going to be commands that we can add into our script list. Like we've got the /speaker, we can also add in some inline commands that change the style of our font. For example, the colour. How about we change hello scratches to be in red? Well then, what we add in between the hello and fellow is a space / and then I'm going to choose just the letter R for red. But you can give these commands any name you like. And now I want to go back to white at the end of fellow scratches, so add a space / W for white, and another space. They always have to have a space before and after the command. Now this is cool. Let me show you how easy it is to extend this text engine with extra effects. Click into the text engine sprite, and we're looking for the process command custom block. Here it is. Right then, so currently we're looking for command of /speaker. Now we're going to look for another command, /R for red. And we quite simply just have to change this current sprite's colour to red, which is easy because our costumes are red, if you remember. So we set colour to 0, that is going to be red, but the brightness has to come back down from 100 to 0. In actual fact, restoring it to its original colour. Then stop this script, since we've processed this command. Let's do the /W for white as well while we're here. Set colour to, well, doesn't matter, set it on 0 still. Brightness back to 100. And stop this script. And drop these at the bottom of our process command custom block. And run the project. And look at that! Can you believe it was that easy? We have added red font and the switching back to white again. And it works perfectly. That was almost too easy. Add as many colour commands as you like. All you need to do is set the colour to another number, like 60, and there's green. See how easy this is? So you could add loads of these colour commands to get the different types of colours that you want. Or, if you want flexibility to be able to choose any colour you want, why not create a command that lets you choose the colour? So if command is /col for colour, then this one, like the switching of speakers, expects another word to follow this command, which is going to be the colour number. So let's read in a new word, get next word from paragraph, and that reads the next word into our word list. So find the word list and drop that into the set colour. Now, whatever word follows our /col will become the colour of this next block. Don't forget to set brightness to 0. Let's test it out by going into the Scratchy sprite, and I'm going to change this to day text. So at the very start of this paragraph, write /col, then a space, and then a number for the colour, colour number 120, and another space, followed by today we are. And now run the project. And there we go, we have changed the today we are to blue. How cool is that? What's more, on the fly, we can choose any colour number we want. How about 90? And run the project again. And now we've got a light green. So this is super flexible, and you can see how you could code your own commands that can do really complex things. To change the text back to white again, of course, we use a /W. There we go. Now, talking about more complex things, how about some of those funky effects that you see in some rather awesome games, where the text actually animates and moves, like in a hypnotic wave pattern? Yeah, let's do that. So we're going to need a command for that. So I'm going to try and add mine around this continue our text engines. And I'm going to use a / as always, and then a symbol, the tilde. This is like a little wave in itself, and I quite like that because it gives a good impression of what we're going to be doing. And now to turn off the effect again, we simply do another / tilde at the end. So it turns on, and then it toggles it back off again. Now, do you think this is going to be hard to code? Well, think again. Into the text engine sprite, still in the process command custom block, we're going to need a new if, checking to see if the command is /tilde. Or is that pronounced tilde? I'm not sure. So this is quite an adequate way of detecting the /tilde command, but because there's going to be potentially lots of these on-off commands, let's do this a bit more cunningly to avoid us having to recode this toggling feature of on and offness. And I'm going to assume that all of these commands are just a single character, well, a / followed by a single character. So the length of this command will equal 2, a slash and a character. And when we come across one of these, we're going to set it to a new variable, the effect variable, for this sprite only. So set effect to the second letter of our command, which is going to be the tilde in this case, letter 2 of command. Okay, so that sets the effect. How do we toggle it back to off again if the same effect is repeated again later on? Well then, we just need an if-else, and we should compare the current effect using equals the effect variable. If the current effect already equals the command, the second letter of command, then we want to toggle this effect off. So duplicate that set effect, and in the top then just set it back to the empty value. So when you try and apply the same effect again, it blanks it out. Otherwise, it changes the effect to the new effect you're trying to apply. And we stop this script. Cool, so that's a way of applying the effect, but a slight word of caution, we should try to make sure we leave this if at the bottom of this script, because it just kind of mops up any leftover single letter commands and assumes that they're effects. So if you want to add any other custom single letter effects, like my color changing ones above, you should do those above this if. Now, interestingly, if you want to run the project, you can actually see this effect being applied as it goes over those words and then turns off again afterwards. So that's good, that seems to be working. All we need to do now is actually implement it. And where we implement this is in the when I start as clone scripts. If you can find them, that is. Okay, here it is. So this is the first when I start as clone script, which is the only one we've got at the moment. And notice how it's already recording the position that we want this text to appear at in target X and target Y. So that will come in very useful. So we're going to leave that as it is and create a secondary when I start as clone script. And this one is going to deal with all our special effects. So have an if and check to see whether the effect is set. So when the effect is the tilde, then we want to start jiggling our letters up and down. To do that, we'll use a set Y to the target Y. This is the point we're going to jiggle around. So then we're going to add in a change Y. And to make a sine wave, we have to use a multiplier. And we don't want to move up and down very much, so let's just choose a small number like 3. And then we multiply that by the sine operator. On the right side of the sine operator is the timeline. So again, drop in a multiplies and put the timer variable in there. And then we're multiplying it by, I don't know, 180. That'll go up and down roughly every 2 seconds. And then if you run the project, you'll find that we have actually made a big mistake. The text is not jiggling at all. And it's obvious why. The when I start as a clone runs once, setting the position, and doesn't loop. Whoops! Right, find a forever loop and pop that around those blocks. And let's try that again. Clicking onto the next screen. And there we go. The whole text is bobbing up and down in a beautiful sine wave. Not what I promised you. So the problem here is that every letter in this text is going up and down at the same time. We need each letter to have a slight offset so that it kind of goes in a nice wave. To do that, we need to add to the right-hand side of the sign based on the position of the letter in the string. So multiply the X position of this sprite, this letter, by, say, 5. And then put that in an addition and add that to our timer. Now, each of the letters is going to be given a slightly different position on the sine wave, and that gives us that beautiful up and down effect. Isn't that cool? And you can have so much fun playing around with the values in this mathematical equation. Change this value here, multiplying by the X position, to have a kind of longer or shorter sine wave. Play with the values on the right-hand side in the timer to make the sine wave move faster. Whoa, very wiggly. And you can also play around with the first value to get a bigger sine wave. I'll let you have a play with that one. Because I still have more to teach you, the next effect I want to try adding is the shake effect, or the shiver, and that is really funky. To be honest, I expect that you could probably implement it yourself right now. If you want to have a go, then go ahead and try it. But for those who want to see me do it, let's have a go at it now. I'm going to apply it to Nano's bit of text here where it says much more text. So /, and I'm going to use the hash as a kind of shake. And then at the end, another space, / hash. Okay, back into the text engine, and let's see if we can implement this. So the application of the hash to be an effect should already have taken place. All we need to do is check for if effect equals hash in our whenStarters clone. So duplicate the existing effect and change it to be a hash. And we'll have the forever loop as before. But this time I'm going to reset the position of the text to be the target X and target Y exactly. So we will have a goToXY, dropping in the target X and Y in the relevant spaces. Okay, so that keeps it grounded at the position it's supposed to appear. Now we want it to shiver, so we're going to change X, and we're going to change Y by a random number. So pick random, and I find the best results are from 0 to 1, and just duplicate that into the change Y. And that, my friends, is all you need to do. Run the project again. So this is the Nano, and there it is! Doesn't it look great? All shivery, like it's a scared little bit of text. I love that, and it's so useful for so many things. Although I think you could probably make that effect even better if you worked hard at it. Best thing to do is always analyse some examples, maybe find them on YouTube and see what they look like, how they're moving, how the timing is, if they're getting bigger, smaller, or if they're moving maybe at a slower rate, who knows. Have a go at it, see if you can make an effect that you like. But for now, pick random, 0 to 1, does the best for me. Okay, wow, we've done so many things now in this episode. But there's one more thing that I want to add before we finish, and that is to do with timing. At the moment, each page of text outputs at the same pace. It doesn't allow for any pauses for dramatic effect, and that is what we're going to add next, the ability to pause the text mid-flow. And this too is going to be a command, so find the process command script. And remember what I said about not adding short commands to the bottom any longer because of our length command equals 2? Well then, let's add it to the top of this script instead. So as always, we're going to need an if condition, checking command, and the new command I'm going to add is going to be /, as always, and then just the number 1. I must reiterate, these commands, you can call them whatever you like, whatever seems best to you and looks best in your dialogues. So /1 for a short wait, and it's not actually going to be a 1 second wait, I'm going to make it even smaller than that, wait 0.3 of a second, a really short wait. Problem is, this wait doesn't allow the user to interrupt it. You know when we press space to skip the dialogue? Well, we need to allow the user to be able to interrupt even these dramatic waits. So we're going to create a new custom block called wait with an input of seconds. The idea being that we can just drop in this wait in place of our existing one. So wait for 0.3 and remove the old wait command. Okay then, so this wait wants to be interruptible by the user. So it's going to be a repeat block. Repeating for, and then we need to multiply, seconds multiplied by 30, because Scratch runs at 30 frames a second. So once 30 times around this loop has occurred, it will be a second, as long as within this we're waiting 0. That means wait to the next frame. So wait for 30 frames, it'll be a second. We can test that. If we wait for 2 seconds and click it, 2 seconds later it unhighlights. See? Perfect. Right then, now we need to make it interruptible by the user. So pop an if above our wait, and then we're going to look for the skip dialog. So greater than, skip dialog is greater than 0. Then we don't want to wait at all, so we want to exit out of this custom block. And we do that with a stop this script. Cool. So back up to our if command equals /1. We also need to stop this script in there, like we do with all the other commands, and then drop that in at the top of our process command script. Nice. So we want to test this, but we haven't used it yet in our dialog. So in the add to script in the Scratchy sprite, let's add in a delay after we say fellow Scratchers. /1, always having spaces between commands. And run the project, hello fellow Scratchers, and a small delay before saying how are you today. Oh, I just ran the project again, and everything is jiggling up and down. It appears we have a little buglet. I mustn't be resetting the effects when the project starts. In fact, I suspect it's probably best to put it in at the start of our play script from start to end. If we set effect to the empty value anywhere in this top section of the script. Okay, now, let's just run the project again just to make sure that works. Yeah, that's it. We've reset our effects. Good. That was a good spot before we continued. So what were we up to? Ah, yes, we've just added in the /1. Let's add a few more of these /1s in between each word for full effect. Run that again and see if these words come out slower. How are you today? So we could add lots of different commands for different types of delays. You could even add new commands that caused each of the letters to come out individually really slowly. Lots of things are possible. But what might be quite useful is to be able to specify an exact amount of time you want it to delay at any particular point. Like you might want to just pause after one sentence for an extra long amount of time and just specify I want it for 5 seconds. For example, /wait space 5. Should we implement that command? Find the process command in the text engine, and we're going to duplicate the /1 command. This time looking for /wait. And like the other commands with multiple tokens, we pop in a get next word of paragraph, which will give us back the amount of time we want to wait, and then we want to wait for it. So find the list variable for the word, drop the word into wait, and that should do it. Run the project and let's see if it waits for 5 seconds. 1, 2, 3, 4, 5, now. Yes, we were spot on. Isn't that so cool? You know, I am so excited by the possibilities opened up by this cool dialogue engine. And all you have to do is backpack the text engine and the dialog box sprites and drop them into your project and create something awesome. For example, this little test project I showed you at the very start of this mini-series. And here you can see the dialogue does not start up straight away. No, it waits for us to press an action key. And then we have these scripts down here that dump our commands and our dialogue into the script list. And you can see how it changes what it's going to say based on what's happening in the game. So if I'm near Nano or not. And then we broadcast and it starts up the dialogue conversation. And then once that conversation's finished, the broadcast ends. Our gaming scripts can continue again, and we can code up the next part of our game, for example, allowing us to walk closer, and then start up a new conversation with Nano with a different set of dialogue. So, like I say, to bring this into your own projects, just remember to backpack both the text engine font sprite and the dialogue sprite. And be aware that the speakers list is declared for all sprites, and as such, it doesn't actually get saved in your backpack, which is a little bit annoying. So that is why I added these helpful scripts into the dialogue sprite to help you set up the values in the lists when the project starts. That makes it backpackable, and it doesn't matter about the list then, because it's all in the scripts. And so, that brings us to the end of this text engine mini-series, and I hope you've enjoyed creating your own awesome text engines with me. I'm so looking forward to seeing how you put this to use and how you might extend it even. Perhaps adding more effects, sounds, and different dialogue positions, I don't know, anything. If you have any questions or feature requests, then do comment them under this video. But that is the end, so until next time, have a great week ahead, and scratch on, guys.